Assalamualaikum and hello to everyone. So today I am Muhammad Hadzim as representative number 1. So today my group want to discuss about the use of the hydrocarbon refrigerant in the air conditioning and refrigeration system. Firstly, this is my group members. First, Muhammad Hadzim, me. Second, Muhammad RAZIQ AFIQ bin ANUAR. Third, Muhammad Ashraff bin ZULKUPLI. Fourth, Muhammad FIRDAUS bin YUSDIANTO. And lastly is Muhammad IQMAL bin MOHAMAD ZAIDDIE. Okay. First of all, the introduction of the hydrocarbon refrigerant. So first thing first, the traditional vapor compression refrigeration technology are employed in most refrigerator and air conditioning unit VCRS. However, on the other hand, the chlorine in ozone depleting chemicals like CFC and HCFC interact with ozone and destroy it. So aside from chlorine and bromine in HFC, they are greenhouse gases that impact Earth's global temperature. As a result, each of these refrigerant has a significant negative influence on the environment and contribute to global warming. So this refrigerant must be replaced by hydrocarbon refrigerant with low ozone depletion potential ODP and global warming potential GWP to address global environmental challenge successful. So the subtopic number 1, hydrocarbon as alternative refrigerant. So the researcher by Harvey and al. 2016, the researchers say that each of this chemical has a unique chemical and thermodynamic properties. They share two important environmental characteristics with no ODP and very low GWP. So the hydrocarbon refrigerant such as dimethyl ether, cyclopropane, propylene, ethane, isobutane, butane and propane. So all of this has zero ODP and less GWP. So next, by Hamad and Al-Assad 1999, June and all 1999, Kedru and State 2020. The three papers say that the hydrocarbons combine good thermodynamic qualities with energy, efficient physical and chemical features. So lastly, from Dakilik and Wong Weiss 2010, the researchers state that the hydrocarbon refrigerant offer good energy saving while maintaining high system performance, making them suitable as long-term substitutes for refrigerator and air conditioning refrigerants. That's all for me. My friend will continue the next subtopic. Thank you.
Hello, my name is Muhammad Ashraff bin ZULKUPLI. Welcome to my section. In my section, I'm gonna talk about the characteristic of hydrocarbon refrigerant. As you know, hydrocarbon refrigerants are natural, non-toxic refrigerants that have no ozone depleting properties and absolutely have minimal global warming potential. Besides that, hydrocarbon refrigerant also is the most efficient and environmentally safe refrigerants in the world. Hydrocarbons refrigerants is one of the 5 natural refrigerants, which are air, water, carbon dioxide, ammonia, and hydrocarbons. The hydrocarbons refrigerant is composed of hydrogen. This refrigerant also easily dissolves in mineral oil. Furthermore, the reason this type of refrigerant have increased its popularity because it has thermodynamic properties such as propane. However, even though this refrigerant is good for use, but this refrigerant also have a bad side. The hydrocarbon refrigerant is also known as a flammable refrigerant. This means this refrigerant is sensitive if there are any sparks happen. They are extremely flammable when compared to other commonly used refrigerants like HFC and HFO. Eventually, hydrocarbons refrigerants are 50% more efficient conductors of heat than fluorocarbon refrigerants, and their operating pressures are about 20% lower than that of fluorocarbon refrigerants. This lower operating discharge pressure reduces the work that compressor has to do, thus reducing wear and tear. To conclude, in all applications, hydrocarbon refrigerants are much safer for consumer than chemical refrigerants, even though the hydrocarbon refrigerants has been prohibited in several countries because of the flammability issues. Lastly, the picture shows the highest flammability and the toxicity refrigerants to the lowest. Thank you. I give to the next person.
Assalamualaikum and hi everyone. My name is AFIQ bin ANUAR. So I shall continue with the subtopic 3, which is the performance of using hydrocarbon. Alternative refrigerants have been suggested in the last 15 years, such as hydrofluorocarbon (HFC) with no ozone depletion potential. HFC are hazardous refrigerant for environment and they are hence facing ban in some other country. P.J. van der Weydt was the first to demonstrate the use of hydrocarbon as a refrigerant in 1866. Hydrocarbons such as ethane, propane, and isobutane were easily acceptable in the early 1930s since the synthetic refrigerant were developed due to its chemical stability and very low flammability. Okay, moving to the next slide, which is the example of hydrocarbons refrigerants. There are four, which is ethane, propane, butane, and isobutane. Okay, most of the hydrocarbons refrigerants are successfully used in the industrial and commercial installation. They possess satisfactory thermodynamic properties, but they are flammable, and some of the various hydrocarbon refrigerants are given in the following table. So nowadays, R134A refrigerant is the most commonly used refrigerant in domestic refrigerator, which is causing serious environmental effect. So to overcome this problem, there is need to change the refrigerant, where we have used the R600A as a refrigerant, which is examined for the comparison of COP of R600A and R134A. R134A is a long-term replacement refrigerant for R12 because of having favorable characteristics such as zero ODP, non-flammability, stability, and similar vapors pressure as that of R12. The ODP of R134A is zero, but it has a relatively high GWP, which is the global warming potential. Many studies are being carried out which are concentrating on the application of environmentally friendly refrigerants in the refrigerant system. The issues of ozone layer depletion and global warming have led to the consideration of hydrocarbon refrigerants such as propane, butane and isobutane, or hydrocarbon blends as working fluids in the refrigeration and air conditioning system. Moving to the next slide. Okay, this is the table of HFC, CFC and HC. In comparison of HCFC, HFC and HC, HC provides zero ODP and very low GWP as shown in the table. They also offer good efficiency, lower charge sizes, good compatibility with mineral oils, lower compressor discharge temperature and more efficient heat transfer. But they are highly flammable and this limits their usage in the large system. Two most commonly used hydrocarbons are isobutane, which is the R600A, used in domestic refrigeration, and propane. Hydrocarbons are generally non-toxic. Hydrocarbons has the advantage of providing an increased efficiency of 14 to 20% in vapor compression system, and since its density is only 40% that of HFC, the refrigerant charge it used is much less. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad IQMAL bin Muhammad ZAIDDIE. My matrix ID is B0918102231. Okay, so I would like to share for our fourth subtopic, which is standard and guides for safe operation of hydrocarbon refrigerant. Okay, for the first slide, we have 2 points here. The first one is good and safe design may overcome the flammability issues of hydrocarbon refrigerant based on standards and safety guides. Okay, so the second point here is the American Society of Heating, Refrigerating and Air Conditioning Engineers, or the short form we call it as ASHRAF, have produced several well-adopted and authoritative standards. Next, here we have 3 standards pertain specifically to the safe use of hydrocarbon refrigerant that have been promoted or shown by ASHRAF. Okay, the first one we have standard 15, safety standard for refrigeration system, and then the second one we have standard 34, designation and safety classification of refrigerant, and then the last one we have standard 147, reducing the release of halogenated refrigerants from refrigerating and air conditioning equipment. So the third slide is about European Union. Other than ASHRAF, European Union, or the short form is EU, also having actively promoting environmentally friendly policies, have promoted the EN 378, which deals with refrigeration system and heat pump safety and environmental requirements. Okay, there are 4 parts in the slide. The first one we have basic requirements, definitions, classification and selection criteria. And then the second part we have design, construction, testing, marketing and documentations. And then the third part we have installation site and personal protection. The last part, the fourth part, is operation, maintenance, repair and recovery. So for the fourth slide, we have refrigerant safety classification scheme. Okay, as we can see, there are table about classification for refrigerant. On the right side, we have toxicity, which is divided by 2 classes, which is class A and class B. Class A is about lower chronic toxicity, and then class B is about higher chronic toxicity. And then on the left side, we have flammability. They are divided by 3 classes. The class 1 is no flame propagation. Class 2 is lower flammability. And then class 3 is higher flammability. Okay, hydrocarbon refrigerant are very combustible but not harmful. In the table, hydrocarbon has class in A3, which is lower chronic toxicity but higher flammability. Hydrocarbon is primarily the lowest hazardous refrigerant concentration with a safety factor added. Okay, so for the fifth slide, we have 3 steps that use to calculate practical concentration limit or PL. Okay, so for the first step, we have acute toxicity exposure limit (ATEL) based on mortality in terms of LC50 or cardiac sensitization, as well as anesthetic or central nervous system (CNS effect). The second one is limit of deprivation, which is ODL. And then the third one is a reduction of 20% in the lower flammability limit. So the last one is 20% of the lower flammability limit indicates the lowest concentration of the above for hydrocarbon refrigerants. This is the features utilized to determine the PL. When hydrocarbon escape from the air conditioning, guides and standards are used to guarantee that only a small quantity of hydrocarbon refrigerant is charged into the system, reducing the chances of the mixture of hydrocarbon and air meeting the lower flammability limit values.
Hi, I am MUHAMAD FIRDAUS bin YUSDIANTO. Okay, the conclusion for this topic, which is the use of hydrocarbon refrigerant in air conditioning and refrigeration system, is from the thermodynamic, thermophysical and heat transfer perspective, is that a number hydrocarbon are acceptable as refrigerant. Okay, all hydrocarbon have excellent environmental characteristics such as zero ozone depletion potential in bracket ODP and a low global warming potential in bracket GWP. Okay, in terms of performance, several research conclude that hydrocarbon and their blends outperform hydrochlorofluorocarbon in bracket HCFC and hydrofluorocarbon in bracket HFC. This finding should serve as more evidence that hydrocarbon are the preferred replacement for HCFC and HFC. Okay, the following conclusion can be drawn based on the finding of many research and the previous hydrocarbon. Firstly, thermodynamic and thermophysical properties of hydrocarbon are more convenient than those of usual refrigerant. Second, hydrocarbon can be used as a replacement for HCFC refrigerant, which is not only environmentally beneficial but also save energy. Hydrocarbon also show unusual behavior alternative to conventional one in terms of energy efficient COP, refrigerant charge and compressor discharge temperature. Then blends of hydrocarbon and hydrofluorocarbon combination can be used to repair CFC and HCFC system, giving the same lifespan as before. Even though hydrocarbon are flammable, most research employ low refrigerant loads in large capacity system. Okay, hydrocarbon and hydrofluorocarbon mixture have been proved to be good alternative to R12 and R134A in household and commercial refrigeration system, giving the widely available international and regional standard and recommendation for the use of hydrocarbon and other natural refrigerant, it is right to purchase the law on the use of hydrocarbon be established in Malaysia to increase its safe and efficient usage in the air conditioning and refrigerant industry. That's all.